Today we are continuing with Unit 9, combinations, permutations, and probability. And the key thing I want you to think about today is that I think Unit 9 is really exciting, but the thing that you have to understand, it is all about logic and how you can use your critical thinking skills to apply the logic to come up with specific answers. So let's say, let's start with some number logic. Okay, so let's say I have numbers 1 through 20. So I'm just going to write them all down. 1. And we had to, let's say we have to determine the number of ways we can generate such, let's say, even integers. If we were to do 1 through 20, well, there is 2, 4, 6, 8, 10. So there's 5 on the first row, 5 on the second row. So there are 10 ways in which we can do 10 even integers. What if we wanted to say how many ways can we generate that are multiples of 5s? Well, they're multiples of 5s. We have 5, 10, 15, 20. Well, there are 4 multiple of 5s. Let's think of another. What if we wanted, and one is divisible by 3? So let's count that. Divisible by 3, we have 3, 6, 9, 12, 15, 18. So that's 1, 2, 3, 4, 5, 6. So there are 6 divisible by 3. And so knowing these integers and what numbers are in there, we can easily go through and answer any questions. What if they asked for 2, how many of these sets, let's say from 1 through 20, if they wanted sets of distinct integers who are, sum is, let's say 8. Keyword here being integers, so they have to add up to 8. So let's think about this. 1 plus 7 makes 8, but then 7 plus 1 makes 8. So that's one set. That's 2 ways. There are 2 plus 6 and 6 plus 2. That's 3 ways. That's 4 ways. 3 plus 5. That's 5 ways. And 5 plus 3. And that is 6 ways. We can't do 4 plus 4 because those are not distinct integers. The 4 has to replicate itself to add up to make 8. So technically, we have 6 ways to add up to 8. Now let's talk about choices. When we talk about choices, imagine this little blue dot is you. And let's say you go to a restaurant. And in this restaurant, you plan on having 3 courses in your meal. You plan on having an appetizer, so appetizers. You plan on having your main course. And then you plan on having a dessert once you are done with your main course. So let's say your appetizer there, you first get to choose. Let's say they have 4 different types of appetizers. So from here is you. From there, you can go one of 4 ways, right? Because you are gonna buy an appetizer. So there's 4 different types. So here are 4 different types in your appetizers. Each one of these is a possible outcome. So you probably have done a tree diagram before. And then from there, you can have, let's say they offer 3 different types of main courses. So from each path that you choose, they then can also have 3 different types of main. So each one of these will have 3 different types of main appetizers. Okay, my picture is going off a little skew, but each one can have, and let's say there's 2 different types of desserts. I'm going to make those circular. So let's say we have 2 different types of desserts here, 2 different types of desserts here, and each one of these is a different particular choice that you yourself can go. So like each one of these is a is an opportunity to try. So the number of circles then at the end. So let's say this is you here. We start here. This is you, and you want to choose this this type of appetizer, and then from that appetizer you want to choose this main course, and then from that main course you want to have this meal. So this is one possible choice. If you count how many there are here the total number of circles will be the total amount of main courses that you have. So you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So there are 24 different choices that you could, possible choices of meals from having just the choice of 3 appetizers. No, 4 appetizers. I'm sorry about that. 4 appetizers, 3 main course, or in 2 different types of desserts. You have 24 different choices. So that is one way that you could do this. But here, we're going to try to show you this different path. Instead of just saying, making a tree diagram, we can make each choice a box. And because the choices stack with one another, like as you go from appetizers to main, each one of them stack. The 3 main courses stack with each individual appetizer courses. So you multiply as you get each choice. So here you are given 4 appetizers as a choice, and it could be any 4. 3 main courses as a choice, and then finally 2 desserts. 4 times 3 times 2 is also 24 choices. Or 24 possibilities of results that you could get. Okay? And this second method, even though the first method allows us to see visually and understand what we are doing, the second method allows us to, it came from the first, it allows us to manage bigger numbers. Each one of those boxes being one particular option. So let's do some examples with this. Let's do a license plate example. And the license plate example, let's say we have So we have a particular state that allows us to do a license. In our license plate, there are six possible combinations. But let's say the license plate, the state says, okay, we have 2 letters followed by 4 different numbers. So I'll draw a box for each one. So the first 2 are letters, but the state doesn't want any confusion. So the first 2 letters, we cannot have an I or an O. So we cannot, I's and O's are out because they don't want them to be confused with numbers. But any one of these numbers, the 4 numbers following, can be numbers. So these are numbers, and the first 2 are letters, but excluding I's or O's. Well, we then just have to multiply each possibility. Normally, there's 26 letters in the alphabet, but we took out I or O as possible numbers. So the first set is actually 24. And this is a permutation because there are 24 possible numbers. We're going to multiply 2. So 24, the second set being a 24, because we can use any 24 of the alphabet except for I or O. Numbers are digits, are from 0 through 9. Integers, singular digits, there are 10 digits, right? From 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So there's actually 10 and 10 and 10 and 10. And these are all possible combinations. So then we go through and multiply them out. We should get 5, 7, 6, 0. There's 4 zeros here. And so this is all the possible choices, possible choices of combinations, even with those 6 numbers using letters and numbers in that particular case. Let's do another example really quickly. Let's say we have, we're going to a concert and there are 4 couples and they're sitting in one row of the concert. And let's say the first scenario is they do not care where they sit. Okay, so if there's 4 couples, that means there are 8 people. So then there will be 8 chairs. Okay, if they don't care where they sit, that means the first anybody could sit in the first chair, right? So in the very first chair, there are 8 possible people choices that you can pick from. So from there's 8. However, once that first person have sat down, there's 7 people left. So then the second chair, only 7 of those people can sit down. And then since the 2 people have already sat down, the pattern goes. The next one, you only have 6 possible people could sit. 5, 4, 3, 2, 1. Multiply all of them out. You should get 40,320 possible choices in that combination. Now, let's say, since they are couples, let's say they want to be particular. They say, hey, I want to sit next to my partner. I don't want to just sit next to anybody. I demand to sit next to my partner. Well, then we take this step by step. First chair, I was like, okay, well, anyone could sit there. But then the second chair, that person's partner has to sit there. So there's only one choice of person that can sit there. Then in the next chair, there are 6 people left because 2 people have already sat down. We have 6 possible choices. But then their partner has to sit next to them. So there's only one person choice that could sit next to them. And so now you can kind of see a pattern forming here on how these will sit. So then once you multiply that out, 8 times 6 times 4 times 2, you should have 384 possible choices of their seating arrangements. So what I want to really emphasize is to think hard about the scenario, think hard about if there's a number that's going to be taken out in each and every single case.